Good morning. Let's start by getting logged into Clever. All right, let's start with this little icebreaker. Which of these seasons is your favorite and why? Thank you guys for being here for live lesson 19. We have made it to week 10. That's nuts. But we are going to focus specifically today on how we draw a visualization of what the atom looks like. As always, the reminders, please make sure you're checking assignments, make sure that you're getting things done, make sure that you're submitting things correctly, that you are checking for comments or reminders or additional questions or things that I need you to do. Please do your best to be in the live lessons, but if you can't, make sure you're watching this like you are now. Remember, we are always going to be safe, responsible, respectful, prepared, and here, no matter where we are in our virtual or our real classroom. And we are always going to show each other a little bit of appreciation and love because we are working, we are doing our best, and I recognize that and I'm grateful for that. So like I said, this week we're talking about how we visualize the atom. And the goal is to maybe get to talking later in the week about ions and isotopes, but we'll see how that goes based on our lesson today. So you are going to walk away with two new assignments. One is a reading comprehension activity, number 44, and then number 43 is an activity where you're going to be practicing building these models of the atom, following the rules we're going to go over today. And as a reminder, so it seems like some of us are really kind of struggling with this schedule and how to get through the work in a productive way. Realize these lessons, either the recorded or the live versions, they are imperative and necessary for you to be able to complete the next two assignments. So like this week, before you try and jump into number 43 or 44, I sure hope you are here right now. If you are following this daily schedule, that's great. If not, this is really the order of things that you need to do. Watch the preview for the week, watch the live lesson, the first live lesson, complete the two assignments. Watch the next live lesson, complete the next two assignments. The number of people last week that didn't know how to do certain assignments, and when I'm like, or didn't have any idea what I was talking about, that probably is the case if you don't view these lessons. They're super important in not only teaching you the content, but also showing you how to do the assignment. So we're going to talk about periodicity. Make sure you have a periodic table open. Pretty much all of our lessons for this unit, you'll want to have that. All right, so let's start with this as our warm-up. We practiced this last week of how to calculate the protons, electrons, and neutrons. All you need to do that is this information that is right here for nickel. So start by identifying the atomic number and the atomic mass, round that atomic mass, and then use that information to calculate the protons, electrons, and neutrons. Great. So our atomic number is up here in the top, 28. The atomic mass is down here at the bottom, 58.693. Because that is above the 0.5 threshold, we round that up to 59. The protons are the same as the atomic number, 28. The electrons are the same as the protons, so also 28. The neutrons, then, you take that rounded number, 59 minus 28, put that in a calculator, it is 31. Good job, y'all. This is an important step in what we're learning today, so let's make sure that we are in full understanding of it. All right, so the atom. We're going to be learning about the Bohr model today. That is the way that we visualize the atom. And the good news for you is that that's the structure or the model that I've pretty much been showing you from all along. The Bohr model states that there is a nucleus in the middle where the protons and the neutrons are, and the electrons are in the outside in these things called shells. Now, we're going to dive into that more in a second, but the good news is that you've seen this before. A big piece to being able to do the Bohr model is literally just being able to calculate the protons, electrons, and neutrons. If you're still not feeling comfortable with that, go back to last week, make sure that you've done the Kahoot practice, make sure that you've done the lesson, and get comfortable calculating these three. All right, as a reminder, one more time, we got our atomic number. It's always going to be at the top. The atomic mass that gets rounded based on what the decimal is. We want to round it to a whole number. So this is above 0.5, so that's going to round up to 16. Our protons are the same as the atomic number. Our electrons are the same as the protons. And the neutrons, you take the rounded mass minus the protons to give you the neutrons. If you can do that, then you are good to go from here. So this is Niels Bohr. He's the guy who came up with the Bohr model. He was playing around with with different elements and introducing them to heat or light to see what happens. This was called the flame test. And so think about when you watch different things burn in a fire, or if you watch fireworks, right? The different lights are because different color lights that come off are because of the different elements that make up whatever's inside of that. And so what he saw is that these different elements produce different lights. And what he theorized that meant is that the electrons that are orbiting the nucleus are in these energy levels. And when you add that heat or electricity to them, they go out to a higher energy level and then fall back. When they fall back, they release a wavelength of energy that we see as light. So he said that these electrons are orbiting the nucleus in these orbits, in these shells. We've already been using that name. And he said that then there is a specific amount of each of electrons that can be in each of these shells. So the first shell, that's the one that's closest to the nucleus, it can hold up to 2 electrons. The second shell or orbit can hold up to 8. The third can hold up to 8. And then when we get up to the fourth and higher, it gets a little weird. We're not going to really do anything up that high, but for our case, we'll say also 8. So Bohr said that the electrons fill the orbitals closest to them first and then fill out from there until you've placed all of your electrons. So if we take a look here, what this is going to look like, you have your protons and your neutrons in the nucleus. All you have to do is write them out. I'm not going to make you draw all the dots. And then you are going to you add 2 electrons to the first shell. You can add up to 2. 8 up to 8 in the second, up to 8 in the third, and then the fourth, again, I said is a little weird. We'll say up to 8 for our case, okay? So let me walk you through this. You have to start, again, I said, first step is by calculating the protons, electrons, and neutrons. So if the atomic number is 8, we know our mass is going to round up to 16, okay? We know the protons are 8 because that's our atomic number. The electrons are also 8 because the protons are 8. And then the neutrons, you're taking the mass minus our protons, so 16 minus 8. The protons and the neutrons, they go in the nucleus. And then we have our 8 electrons that we have to place, okay? So the key thing here is that we realize that we have 8 total to place. So we start in the inside shell. Now that inside shell, we cannot put all 8 because the inside, that first shell can only hold 2. So if you put 2 electrons in there, we've placed 2 of our 8. Now, how many electrons do we have left that we need to place? So we have 6. The good news is the second shell can hold up to 8. So if we place our remaining 6, 1, 2, 3, 4, 5, 6, we now have an atom that has a nucleus with 8 protons and 8 neutrons. And electrons, we have 1, 2, 3, 4, 5, 6, 7, 8, with 6 being in our outside shell. Great. So let's try this one on our own. I'm going to kind of walk you through this in a couple of steps. Awesome. So what this will look like is a nucleus with 3 protons and 4 neutrons. You'll have 2 electrons in the first shell, and then 1 electron in the second shell to get to the 3 total electrons that this atom has. Let's try it again. Again, I'm going to kind of walk you through this. We can't totally visualize it, but as long as you can tell me what goes where, then you're good. Okay, so our nucleus for carbon will have 6 protons and 6 neutrons. There are 6 electrons that have to be placed. We can put 2 in our first shell, and then to get up to those 6, that means we have 4 more we need to place. You put 1, 2, 3, 4 in the second shell. Good job. All right, so your assignment this week is going to have you doing some more practice of building these Bohr models, as well as doing a short reading comprehension. The reading has a text and then some questions. Please do not go Googling. Do not go Googling the questions to find the answers. Literally go into the text and you can pull it directly from there, okay? So those are the 2 assignments you're looking at. I want to really quickly talk to you about how to do the Bohr model practice. So what it's going to look like, each of you is going to get your own Google slide. And what it will look like, it will start with this, put your name and your period, and we'll have some introductions and instructions with some links that you might want to use. it follows the steps that we just did all together and reminds you about how many electrons can have in each shell. There's an example here for you to follow. So you start by calculating the protons, electrons, and neutrons. And then what you're going to do, using the periodic table, then you are going to copy and paste Control C and then Control V to get electrons that you can then move and add to your shells. Okay? So there are 4 examples for you to do. If that's not something that you feel great about, other options, I'm totally fine if you would want to draw it out, or if you wanted to go to the Colorado PhET and use that to simulation, if that's kind of easier for you to navigate, that's also totally fine. So with this example here, if I calculated I need to have 3 protons, 4 neutrons, and 3 electrons, I could go 1, 2, 3, and then there's 4 neutrons, and then there is 3 electrons. And you want to take a screenshot of that, that's fine with me too, because you built the same atom as I have right here. All good for me. All right, so we're going to finish with an exit slip and send you on your way, as long as you don't have any questions. Questions are good, Gal. It's totally fine. All right, let's finish with this exit slip, and then good luck and get that work done for me. So take a look here. What do you notice is wrong, or what might be wrong with this Bohr model? Awesome. So you should have noticed that that first shell has 4 electrons in it. The first shell can only hold 2. All right. Good luck on these 2 assignments, and I will see you for the next lesson. Bye.